In this video, I'm going to discuss how to factor quadratics such as the following. X squared plus 5x plus 6, x squared minus 3x plus 2, x squared minus x minus 20. All right, so these are three quadratic expressions, and we're going to be focusing on quadratic expressions with integer coefficients. All right, and we're going to avoid for now talking about quadratics where the coefficient of the x squared is not 1. All right, so first we'll learn how to do these where the x squared term always has a coefficient of 1. Okay, and factoring quadratic expressions such as these will always give you a product of binomials, so product of two parenthesis blobs. Okay, and the question is, how do we find out the binomials? How do we find out what goes into those parenthesis blobs? All right, so I'll just go ahead and tell you that the first one is x plus 2 times x plus 3. All right, and you're going to learn how to factor these. Now, if you're ever unsure if your factorization is correct, just go ahead and FOIL it out. That's one way that you can confirm that it's correct. So if I was to FOIL out this product of binomials, let's see, I get x squared plus 2x plus 3x plus 6. Combine like terms, x squared plus 5x plus 6, and there you can see that indeed I end up with what I started with, the same quadratic expression. Okay? So now, how would we have figured out that factorization? Let me show you, let me give you an idea of the line of reasoning. So we think about how FOIL works. Okay? We're going to have to add the firsts together. We're going to have to multiply the firsts from every binomial. All right. Now, the quadratic has an x squared. An x squared is equal to x times x. All right. So you might be able to see that if we put an x and an x there, that'll give us the x squared that we need. All right. Now, the lasts, the L in FOIL, okay, you can see that we have a 2 and a 3, and that's going to multiply to 6. Okay, and that's good because we had a 6 as the rightmost term in the original quadratic expression. Okay, so if you look at the x squared term, and if you look at the number term, you can figure out products that give you those two terms, and then those will give you the firsts and lasts. All right, well, that doesn't sound so bad, but here's the problem. Okay, there are multiple choices for the number. Okay, we know that 2 times 3 equals 6, but we also know that 1 times 6 equals 6, right? And for other numbers, there'll be even more pairs that would work. Okay, how do we know which pair to choose for the number? That's where the middle term, the 5x in this case, helps you out. Okay, so look at the numbers that I chose, 2 and 3. Can you see that those add up to the middle coefficient, the 5? Okay, that's why that has to be the choice. Okay, if I was to, let's say I was to do x plus 1 and x plus 6. Sure, that'll give me the x squared when I FOIL it out, and that'll give me the 6, but the middle term is going to be x plus 6x or 7x. You see that? So we're not going to want that choice. We're going to want the ones where the numbers add up to the middle coefficient. Okay? Now, if you understood that, then maybe you can do the second quadratic expression. You can pause the video and give it a shot, or I'll work it out now. Okay? In a similar manner. So I know it's going to be two binomials multiplied together. The x squared, so an x and an x. And then the 2, okay, so what multiplies to 2? 1 times 2. Oh my God, it doesn't add up to minus 3. All right? Well, hold on. That's not the only pair. What about minus 1 times minus 2? Doesn't a negative times a negative equal a positive? Okay, so that one multiplies to 2, but can you see that it adds up to negative 3? All right, so that one is how you do that. Or that's how you do the second one, excuse me. So don't forget you can have negative numbers. You can even have multiple negative numbers and they can still multiply to a positive. Okay, that's nice to know. And then go ahead and try the last one if you like. Okay. I'll go ahead and work it out now. So x, and now 20, there's lots of choices for 20. So let's make a list of them. Okay. Well, we've got, what do we have? Well, we can do, and it has to be a negative 20. That's important. So we can do 20 times minus 1. We could do minus 20 times 1. We can do 4 times minus 5. We can do minus 4 times 5. We can do 10 times minus 2. We could do minus 10 times 2. And did I forget any? Let's see. I think that's, well, even if that's not it, we might already have stumbled upon the one that gives us the desired sum. In this case, we want the pair where the numbers add up to minus 1, because that's the coefficient on the x term. All right? So do we have, yes we do, with the 4 and the minus 5. All right? So in our factorization, we'll put a plus 4 and a minus 5. All right? Is it possible you'll have to test several choices, several pairs of numbers? Yes. Is it, in a sense, hit and miss or trial and error? Yes. All right? After you do a number of these, you will get faster at quickly finding the pair that will add up to the middle coefficient. Okay? Now, I want to emphasize that not every quadratic expression can be factored in this way. Okay? If you're not able to factor an expression, it's possible that the expression, nobody can factor it. Okay? It's possible that it's simply not, you can't be factored. All right? So let me give you an example. Suppose instead of, here was the first one, x squared plus 5x plus 6, and that the 2 and the 3 did the trick, right? Let's say instead I asked you to factor x squared plus 5x plus 5. All right, I made a little change. I just changed that 6 by 1. All right, so let's try to factor this one. So the x squared, we'll put an x and an x, and the 5, there's really the only choice, there's the two choices are 1 and 5 or minus 1 and minus 5. Okay? And none of those add up to 5. None of those number pairs. Okay? So there is no way to factor that quadratic expression. Okay? So remember that. Remember, you can't always factor everything, every quadratic expression. Remember, sometimes you need negative numbers to make it work. All right? And remember to check your candidate solutions with FOIL.